Welcome to the Introduction to Femap video series. In this and the next couple of videos, we'll use Femap to go through the steps of creating and setting up a finite element model, analyzing it with NX-Nastran, and reviewing the results. In the previous video, we reviewed the Femap user interface and various methods of inputting commands. In this video, we'll start on the simulation process and see how to import CAD-generated geometry, then clean it up so that it's ready for further pre-processing. In today's environment of 3D solid modelers, the simulation process often starts with geometry obtained from a CAD system. Femap can leverage and import the CAD model from most CAD systems and use it as a starting point to create the simulation model. Femap is CAD neutral and can access CAD data from just about any source, and supports all major commercial CAD programs and data formats, and is kept up to date with the latest CAD product versions. Furthermore, Femap's modeling engine is based upon the Parasolid modeling kernel, which is the same as that used by SolidWorks and Solid Edge. In Femap, select the Import Geometry icon on the Model toolbar. Then select the geometry file you want to import. In this case, we'll select geometry from a machined arm saved as a Parasolid XT transmit file. The geometry scale factor shows the geometry units for this model. Since meters are the base unit of length for Parasolid, a value of 1000 indicates that we are using millimeters. Click OK and the geometry is imported into Femap. Once imported, we need to make sure that the geometry is in good shape. If any problematic geometry exists, it will adversely affect finite element mesh generation later on. In fact, identifying and cleaning up bad geometry is one of the biggest challenges in FE model creation, and can take up a lot of time. In Femap, there are many tools available to help clean up the geometry, but in this example, we'll try the automatic approach. Zooming into the model, we can see that there are indeed some extra points and curves present, which will affect mesh generation. So we can select the Geometry Solid Cleanup command and select the solid component, and we'll just use the default cleanup options. With the successful execution of that command, we can see that the geometry has now been cleaned up. In the next video, we'll move on to the next stage and start to set up the model and define the materials, properties, and boundary conditions. In Femap's help system, you have access to a number of worked examples that you can step through to help you come up to speed with the use of the program. Also in the help system is a link to the Femap community. We recommend that you register and sign in. The forum is regularly monitored by the Femap development team, as well as many experienced users around the globe. So if you have any questions, post them in the forum and you'll receive an answer very soon. To find out more, visit us at siemens.com/plm/Femap